just before we get started, my name's Simon Dickinson. I'm the BIM Technical Manager. There's my contact details, so you can find us on Twitter, and there's my LinkedIn post as well. You'll also notice that I've put down there our blogs. All the technical staff at Greytech write blogs on a regular basis, at least one a month at the moment for most people. And you can find them there on our UK website. So welcome to this morning's webinar. So before we can sort of understand how BIM can relate to our industry in terms of house building, it'd be nice to sort of understand exactly what the actual BIM mandate was. So if I just unpause my screen, apologies guys, I've just realized my screen wasn't moving on. Okay, so we need to understand exactly what it is that BIM can offer us. So if we go back and we look at sort of exactly what BIM actually is, for instance, if we take this plan that I've got on here, quite often when we produce our drawings, we'll always put on that little disclaimer on our drawing sheets: please do not scale from this drawing. Mainly because we might have printed it as a PDF and it's a PDF we've sent. There's no guarantee that the person that's actually printing that PDF knows what they're doing or hasn't accidentally put it on the wrong size piece of paper, etc. So what we actually have there is a plan with no dimensions, but you can guarantee there's probably somebody out there that is going to attempt to try and scale from that. So if we actually look at what we actually is that we do, is the way that we actually communicate our design intent efficient? So what file formats are we using? Are we using PDF? Are we printing a drawing out that may not be to scale? How do we then control the version of the drawing that's out there? How do we make sure that the site foreman doesn't actually have the wrong set of drawings, that we've not made changes? That maybe due to planning restrictions something's had to be changed, maybe the garage has had to be removed from a particular property. So next thing we do we collaborate? Yeah, how do we get our supply chain? Now from a house building point of view, getting our supply chain involved is key, and I'm going to show you a couple of examples later on of where house builders have actually managed to get the supply chain involved. So your roof truss, your floor joist manufacturers, people that manufacture the other equipment that's fixed in there. How do you get the people that you're buying all your baths? Maybe you're a large house builder, maybe you're a small house builder. How do we get that content? A lot of the manufacturers are getting involved in BIM because they're starting to get asked an awful lot for it, and there are benefits for them providing their product in a BIM format, because if you're using their product to design with, you're going to be purchasing their product later on as well. So it's good advertisement for that. You know, and have we been taking advantage of new technology? One of the things that I do, which is slightly sad, I suppose, is I like to look on the planning portal, mainly for my local area to find out what's going on. But the one thing that I really enjoy is looking at the drawings that have been put up. So sometimes you'll see drawings that have been done using CAD software. You can sort of tell the difference if it's been done in a three-dimensional BIM package. You might see the 2D drawings, but I still see an awful lot on the planning portal of hand drawings. Some of them are very good and some of them are very much a fag packet style drawing, but people are still doing that. Are we actually utilising this new technology and benefiting from that technology? So if you think about BIM, it is what we refer to as a model-based design approach. It's a model-based approach. We're actually developing a three-dimensional model of what we're going to build. More importantly, what we're actually doing is we're creating a three-dimensional digital prototype of what it is that we're going to build. It's not just 2D lines, arcs and circles like a traditional 2D drawing would be. It's intelligent. So the model-based design is way beyond 2D in construction. So these digital models, they're intelligent, they've got data-rich components. So for instance, if I was to select a door or a window, we can find out everything we need to know. We could find out who supplies that window. We could find out what the finish was on that window. Is it a UPVC? Is it a hardwood window? what finishes are applied. Is it a double glazed, a triple glazed? Have we got solar film on the glass, etc.? So we can start to have a lot more information within our products. So the actual design itself becomes a lot more intelligent. And we have this idea of a centralized repository of building information. So once we start to design at an early stage, we're actually already, instead of doing a concept design and then developing it later on, we tend to do more work up front. Whenever you say to people you do more work up front, they always straight away think, well, do I really want to do more work? The truth of the matter is, it's not about doing more work in more time. It's about producing more information in the same amount of time. So the whole process is a lot quicker and a lot more efficient. There's collaborative workflows as well. So the building data can be interchanged. So if we are building maybe a small apartment block where we need to get a structural engineer involved, the structural engineer can be designing in context. He can be designing inside our own design. We can have the roof truss manufacturer producing a roof truss that will fit our three-dimensional building accurately, and they can see how that's going to come together. Yeah, so it does require close cooperation with the supply chain. It's not necessary, but that really will give us the best scenario. And then we can create a virtual construction. So we can basically look at our plot. Maybe we're not just building one house, maybe we're building 3 or 4 houses on a small plot. It could be anything up to a couple of hundred houses on a large plot. The idea that we can actually then simulate that in real world terms is very important. And it's very much a catalyst for change, because one of the things that if BIM achieves nothing, it helps with communication, and it helps to resolve issues quicker as well, even from a house builder's point of view. So this idea of a model-centric approach, automatic design and construction documentation, basically what happens is, as you draw, all the information is being generated as you draw. So for instance, if I draw a floor plan and I put my windows in, my elevations are being generated automatically. So I don't have to draw them separately, because I'm drawing a three-dimensional model. Even though I might be in a floor plan, there is still heights to my walls, there's still offset heights to the windows, we've got head heights on doors, etc. That means that when I go to an elevation, it's already been generated. The other thing we've got is the ability to have what we call multiple design iterations. So this is like design options. I'm going to show you an example later on where a house design is being drawn where the exterior has got the option of either being a brick finish or a rendered finish, and all the information that links to the differences about the construction. It's not just about changing the material, it's about changing the wall construction. So we haven't just got a case of block cavity brick with a render added afterwards. It would be a different type of brick that we would then be rendering over. We've got sustainable design for energy regulation compliancy. So the three-dimensional model that we will be creating, when we actually create that, there's nothing to stop us then looking at doing energy analysis on that. Because of the change ability within a BIM model, being able to make very quick changes or very big changes very quickly. If, for instance, I realized I had to increase the thickness of all my exterior walls because I needed to add extra insulation, I can do that very, very quickly. And we're talking about a change that would happen within a matter of minutes rather than a matter of hours or days in traditional 2D ways of working. We also get the realistic visualizations in there. I actually always say that the visualization side of things, it's actually a byproduct to BIM. Because we're creating a model in 3D, we can get these 3D views out of the software very, very quickly. We can place a camera outside the building or inside the building. We can start to have a look at how that's going to look from a three-dimensional perspective. It's very good for winning clients over. If you were building a house as a one-off for a private client, we can start to very quickly show what that house is going to look like. Because it's a 3D model, even if you're the type of company that outsources your visualization, you've actually already created the 3D information that you need for the visualizations. So it's a case of just passing the model over. It saves time and it saves money at the other end as well. Okay. I mentioned about the construction site simulation and management. We can even start to look at using BIM to actually look at the logistics of site construction, making sure that we don't build the show homes in such a way that we can't get onto the site until the show homes are finished, because there'd be implications of where we actually put in areas, where do we actually put our stores on site, where does all our site equipment live. That's obviously going to be the last plot of land and last area that we can actually build on. How do we actually manage all that? And then probably one of the best features is the quantity takeoff. So if you basically place an object within a BIM model, we can count it. Within Revit in particular, it will count everything that's in there. It will give us very accurate takeoffs for brick, block, plasterwork, any material that we're using, we can get very accurate takeoffs. Now, one of the things that's sort of driven all this in recent years, and what's made BIM even more prevalent, I've been looking at BIM for probably 14 years now, but back in 2008, the government started to actually look at how BIM could actually improve things. So the government came up with this 2016 mandate. So this kicked in April this year, to the extent where some of it's been very successfully implemented, some of it's still going, but we will get there shortly anyway, because there's a few changes that just need to be made. So basically the government looked at what could BIM do for the building industry, particularly as the building industry is always deemed to be a very wasteful industry. We're not very good. A survey I was reading about 18 months ago reckoned that for every pound which is spent on site, 25 pence of that pound is waste, whether that's over ordering of products, mistakes being made on site, people waiting for changes to be made. So we're a little bit inefficient. So we started to look at how BIM could improve that. And from a government's point of view, yes, they were looking at a more efficient way to actually construct, but also they were looking at how we could then look at a building life cycle through from conceptual design to construction, but then over to facilities management. So if you think about the BIM Level 2 mandate that kicked in April this year, from a house builder's point of view, it's probably more important from the government perspective when we look at social housing, where someone is going to be managing that property after it's constructed. Yeah, from a handover where we're selling the house afterwards, we still have a lot of advantages in the way that the design software works, but when you look at what BIM Level 2 is, there's only certain aspects of a mandate that apply to most house builders. So don't get too tied up in there. The benefits for most people from a house building point of view is the speed at which we can design, the change and the data-rich information that we can get out of our model from a construction point of view. So there's various websites that you can go onto at the moment and have a look at what's going on. So we've actually got the level2bim.org website. So this is basically becoming the documents are almost permanent documents. This is where, if you've been looking into it, you'll come across the term PAS. So the PAS 1192 documents in particular that link to the BIM Level 2 mandate. They've also dictated of the government that all centrally funded projects will require a BIM Level 2, and they will complete what we call an EIR. So the EIRs, and I'll talk to you a little bit more about what an EIR is later on, which is the Employer's Information Requirement, basically means that from your point of view as maybe the main contractor, where you're getting your supply chain involved and you want certain information provided in the model, the EIR will allow that your supply chain to understand what information you are asking for within the models. Okay. The ongoing support for Level 2 remains with the BIM task groups, which you may have come across, and that's available on there as well. Now, it's not just about the 2016 mandate. In fact, if we just have a look moving forward, so the 2016 mandate that kicked in April, there is another section to the mandate which will be kicking in this month. And it basically means that from a government point of view, they will actually be validating the information. So again, from a social housing point of view, it may be that this is something that's going to become a requirement for the house builders to provide that. But what's interesting again about what's happening at the moment is that the BIM task group are now moving forward and looking at what we call BIM level 3. I'll talk to you about the BIM levels in a second, because the problem with the BIM levels is they can get a bit confusing. So currently the 2016 mandate was about producing a BIM level 2 standard. We are now looking on the website digitallybuiltbritain.com at what the level 3 strategy is, i.e. how can we take the benefits that we've got so far and improve them and make everything more streamlined. But moving forward, we are already looking ahead from 2016 to 2025. So we've actually got a construction strategy for 2025. And this is now where they're really wanting to try and change the impression that most people get about the building industry being a little bit inefficient. So how can we improve what we're doing? So they've got some targets, and the way in which we achieve these targets isn't as 100% clear yet, but this is all under development. Yeah, we've still got 9 years left, although in the world 9 years is never that long far away. But looking at how we can produce buildings 33% cheaper. And we're not just about looking at the construction costs here, we're looking at the design costs, so the whole cost of a building. Can we deliver that building 50% faster? Yeah. So the government are looking at how we can look at how the supply chains work. The whole way that BIM works means that people can be working in the same space at the same time. Traditional design, and I was with a customer yesterday and we were discussing this, it always used to be that one contractor would do their work, and when they were finished they would pass it on to the next person. They would do their work and they would pass it on to the next person so that they could add their information. It was always very time consuming, because we were always waiting for the last person to finish before you could get started. But why should we do it like that? Why can't we all be developing our designs at the same time, so that the roof truss people are actually already putting the roof in the building when you've got that roof on the building? He's not waiting for you to finish the rest of the information in that model before he can get involved. Lower emissions, how can we make our buildings more efficient? The idea of reducing our carbon footprint, it's more important than ever. It's in the news constantly. But how do we actually control that? With Part L will be evolving to actually allow this. Now, obviously, when we look at the greenhouse gases and emissions in the built environment, it's not just about how green is the building that we build. In many respects, it's also about how green is our construction site. Yeah. When are we going to get hybrid site equipment, hybrid plant? Yeah. I can't see it being a million miles away before that will actually happen. Improvements in exports as well. So basically, the trade gap between exports and imports, with the drop in the pound, obviously our exports are going to go up. So Brexit might actually help in some respects with the exports. Obviously, the imports are going to go up. So it's going to be swings and roundabouts there. But how can we actually produce more in this country and export that as well? So I mentioned about the idea of currently we're looking to aim for what we call BIM level 2, and we've got this idea of BIM level 3 up there in the future. If you ever go to a BIM conference, and there's loads of them about, you can pretty much find one in London on a weekly basis. And one of the questions I always hear people ask at these presentations is anyone here using BIM level 3? And there's always at least one hand that goes up. BIM level 3 does not exist yet. We haven't fully formulated what BIM level 3 is going to be. There might be certain aspects of BIM level 3 that people are using, but you can't actually say you are doing BIM level 3 because it doesn't really exist. So let's go back to the beginning of this cheese wedge, affectionately known, and look at level 0. So level 0 is a little bit like the way that we worked in the past. It could be that we're just doing hand drawings, or we're using something like AutoCAD LT, where we're just drawing lines, arcs and circles, but the information that we're drawing is human interpreted. So when I mean that, you draw an arc and a vertical line, you look at that and you go, oh, it's a door. The only reason you know it's a door is because you've been taught that's what a door looks like in a plan. The software doesn't understand what you've created. So it's not intelligent information. As soon as we move to level 1, there will be a certain aspect of 3D in there. So we might be producing drawings, but the other thing as well is not only are we using 2D and 3D information here, we're starting to look at using standards. So we might have introduced BS 1192. So a lot of the architects' offices that I've been dealing with for the last sort of 15 years, for the last, if we went back, the ones that aren't using Revit yet, they're still probably working to their own standards, they're at level 1. When we start looking at level 2, we're increasing the levels of standards, so we're still using BS 1192, but we'll be looking at the PAS documents, and we'll also now be sharing the information. So from a level 1 point of view, we might produce a PDF, and it's a PDF that we send off to the structural engineer, so the structural engineer's now got the architect's drawing in a PDF. At level 2, we'll be sending them a 3D model, so we're collaborating more efficiently. So the information that's going across is more intelligent, and we're sort of looking at how the building fits together, and we're starting to look at a joint digital prototype, if you like. So that's what we really refer to between level 0, which is uncontrolled 2D drawings, yeah, but could be pencil drawings, all the way up to a 3-dimensional collaborative environment once we get to our level 2. So there are lots of documentation out there that you can actually read to come up to speed with what BIM level 2 is. And I've got deep breath in there. For the plain and simple reason, there are lots. Yeah. So you'll notice that the one thing that I have started off with there is the BS 1192. BS 1192 has been out a while now. So that's the CAD standards that we can follow, that sets out our lines, our layering standards, but also how we document, how we file, etc. We then have these PAS documents. So there's a lot of PAS documents. There's PAS 1192, 1, 2, 3, 4, and now 5. These will describe how a BIM process works. So everything from taking the project from day 1, getting the supply chain involved. There's some good information in PAS 1192.2 on how we actually start to get everyone involved and getting the supply chain involved, all the way through to PAS 1192.5, which is more related to the way that facilities management works. Okay. So, and again, more documents moving forward as well. And then there's other documents out there as well. So there's the CIC BIM protocol. I highly recommend you have a look at that. It's very, very good, because also it gives you some really good information about standards and the type of protocols that you want to actually use in there as well. The CPIX protocol as well basically is it has all the standard templates in relating to PAS 1192, contractual information as well as requirements. If you want to become accredited as well, so you can basically specify that you are BIM level 2 compliant, there's 2 ways of doing it. One is to be able to fill out the CPIX documents, but also the BRE do a BIM level 2 accreditation course, which you can go on, and that will then give you the status as that as well. So I've already mentioned PAS 1192.2. This is the first document that really you want to be looking at, not 1192.1, which would make more sense, but it's the second one that you want. Basically, the assessment of need, procurement, so it's all about getting the supply chain. When we refer to the common data environment, what file formats are we going to use on a BIM project? Are we using Revit? Is it Revit? Is it another third-party package? Are you using Navisworks to do the coordination and the site design, etc.? And basically, it sets out, if you imagine it's your project kickoff meeting, it gets all the parties involved that are going to be involved in this project. Make sure that you're all singing from the same hymn sheet, that you've all basically understand what's going to be required by each other. Yeah, it has this resource assessment form that's in there. So these are the CPIX protocols and the IT assessment form. Again, these are nice, easy documents that have already been produced that you can start to utilize. So all you need to do is print them out, get them to fill them out. Yeah, and you'll be able to see exactly what information is required in there. Okay. Also within there, we also mentioned about having a BIM strategy. So moving forward, the concept of having a BIM strategy means that you are setting yourself up as a company with a BIM statement that basically says this is what we aim to achieve by utilizing BIM. And everyone should have one of these, and you should have it advertised on your website, because if you're an architect that's working with a house builder, then, or even a contractor, the contractor may be looking for someone that is capable of producing a BIM level 2 project. The first thing to do is advertise the fact that you do it, and the best place to do that is on your website. But have a BIM statement. Yeah, I can't emphasize how important that is. And then moving forward, we'd set up a BIM execution plan. Now the execution plan basically will specify how we're going to achieve it. And again, in the 1192.2 documentation, there's all the information about how to set that up. If anyone wants some example execution plans, please get in touch with us and we can come out and speak to you about it in more detail and about how to set up your BIM strategy and your execution plan. So do get in touch with us and we can help you in that direction. Now, as we're developing our models, I mentioned about putting more work in to start with. We still talk about within a BIM project the idea of having a level of detail and level of information. So, we'll still start off at a basic level where the information that we actually put down will be from a conceptual point of view, and then we will develop the model. So we have level of detail, so that's the graphical representation, if you like. Everything from 100, which is like a concept design for maybe an object, all the way through to 400, which would basically be a fabrication specific detail, if you like. The levels in between. And I say we also have the idea of a level of information. So this is the non-graphical content within there. So manufacturer, we'll refer to something called COBE, and I'll talk to you about that in a second. But the other level of information that we want in there. Does this product come with a warranty? If so, how long is the warranty available? Can you get spare parts for that component? And if so, where and how long are the spare parts supplied for, etc. We also, one of the things that we set down as well is, and again sort of within our BIM strategy, is looking at the goals for that particular project. Now this changes, so the deliverables on a BIM project might change from project to project. From a house builder, it might be the fact that on one site we're just building 2 stories, on another site we've got some 3 stories and some apartments. That might mean that the priorities change slightly. So, if we actually have a look at these deliverables on the right-hand side, of the left-hand side, sorry, these are actually from a real-world project. And as you can see there, the most important one was to enhance the quality of the deliverable asset, i.e. produce a better product, produce a better building. Health and safety is still a high one there, down at R3, and then the potential uses of BIM and how we can actually look at our goal and what aspect of BIM is actually going to help us to improve or get to the target. Yeah. So once we've put all this together, I mentioned that the government, and one of the key features that the government were looking at was the idea of using this for FM. So facilities management, looking after their assets afterwards. Now this is where this comes in. So if you're actually doing anything where it could be social or there may be a management company taking over, this is a standard that was developed by NASA, believe it or not. So Construction Operations Building Information Exchange, or COBE for short, was developed by NASA to manage their assets, their building assets. That was then later adopted by the US military, and then further down the line adopted by the UK government. It has been tweaked a little bit, so the UK COBE standards, a little bit different to the US ones, with the information that's in there. But this is essentially an as-built spreadsheet. It's a handover spreadsheet, if you like, that contains information about objects that are in there. So you can look down that list, see there's even a mirror that's been listed. So this is obviously a mirror that's been put on a wall, maybe it's a health centre, etc. So there's some assets in there. But it can also then manage things such as well as furniture. It could be managing wall construction, wall finishes. It could have in there information about the door manufacturer, the ironmongery, windows, the ironmongery on the windows, etc. It's an as-built spreadsheet which contains not just the asset information itself, but other information. So there's some fixed properties that go in here. For instance, installation date, who installed it, what's the warranty start date, how long's the warranty, etc. So all of this information is embedded in this spreadsheet that we can hand over. And a lot of people find this hard to believe, but this is a BIM level 2 document. One of the things that the government were very adamant about when they were dictating that there would be a BIM level 2 mandate in 2016 that everyone would be expected to use, particularly from public funded projects, was that the software was available. Obviously they couldn't specify an Autodesk product or something like that because of the competition, but they actually said that the minimum software requirement would be a spreadsheet package. So whether that was OpenOffice, Microsoft Excel, but as long as it could read an Excel file, that was the minimum software requirements for BIM level 2. And that's where the COBie document, this COBie standard came in, so that everyone was capable of producing a BIM level 2 piece of information. The concept behind COBie is the fact that we actually let everybody know about COBie as we go through the project. So I've basically got the Revit stages of work there, the old one and the new, and also the CIC work stages as well. And you can see that we basically let the end person know about what we're doing with the building from everywhere, from the conceptual stage all the way through to the construction stage. So the COBie Drop 4 will be basically an as-built spreadsheet. Yeah, that's the final spreadsheet that gives us that final information. Okay, so I did mention about the fact that BS 1192 still applies to a BIM project, even though obviously this was redeveloped in 2007. It has actually been developed again, so there's a 2010 version which starts to incorporate a certain amount of BIM changes as well, but we still have information in there which is required. So things like the roles and responsibilities, how the work in progress documentation works, naming conventions for our files, and our layering names. Now I have put an exclamation mark on there because the layering within a BIM package, for instance like Revit, that uses categories, so it's slightly different, but we still utilise the layering naming in other areas of BIM as well. How do you get everyone up to the same standard? Quite often, if you're depending on the type of project you're working on, you may receive one of these CPQ documents. Yeah, so the construction pre-qualification questionnaire. Basically, this is a document that tries to ascertain if you as an individual or a company are capable of producing a BIM level 2 project, and the contractors have started sending these out. If you read a lot of the PAS documents and the CPIX document, that will tell you the sort of answers to put in here. If any of you actually receive one of these documents, try your hardest not to put a tick in the no column, because the no column actually gives you a -1 score when you look at the way that this is marked. So what you need to do is, there might be some questions where you've sort of done it but not fully. Try not to say no, try to give a qualifiable answer, even if it's yes, but we haven't completed a full project on this yet. So be very careful. I'm not saying lie on these documents, but just try and avoid the no answer if you really can. I mentioned about the EIR document. Again, if you're a contractor or you're trying to get the supply chain involved, this is a very useful document that can be developed to make sure that you are requesting the correct amount of information within a project. So does this actually work from a house building point of view? I'm going to show you a bit of an example of one where it's been successful. Now, the one thing to be aware of is BIM is very much scalable. One of the arguments I've always had over the years is the fact that, yeah, BIM's really, really good, but it's only good for big projects. It's like the skyscrapers of this world and the World Trade Centers. Well, yes, it is, but it doesn't have to be. Probably back in about 2004, I was doing a presentation. It was called From Bat Houses to the Freedom Tower, and it was the smallest project that I'd come across at the moment, that time, that had used BIM. It was actually some bat houses that were actually built on a site of a school where they were knocking the school down, but they'd found bats. So they'd actually built some temporary accommodation, if you like, for the bats. But that was done purely as a BIM project. Yeah, so BIM really is scalable. So if we look at Worthing Homes, so the pilot project for affordable housing, 12 houses in 3 blocks, and it was part funded by TSB, or basically that company is now known as the Innovate UK. And the idea was they wanted to be able to study the behaviours across the whole supply chain and see how they could get the supply chain involved. PMC Construction were the main contractor, ECE Architecture were the main architect, and the project value wasn't a lot, so it was only 1.5 million for 12 homes. Yep, so we weren't looking at massive sort of values here. But what basically benefits could they see? Yeah, so for the housing positives that they could see, well, there was great potential for off-site manufacturing. More and more now we're looking at ways for prefabricating. If you ever go to a Premier Inn or a travel lodge, they are all the new ones are prefabricated. They're all modular built off-site. Modular construction's a safer method. The modules can be built in a controlled environment, very much so, before they're actually shipped to site. You don't need as many personnel on site, again, cutting down problems. The early use of the modelling tools basically give them a good idea to provide improved layouts. It was very quick to start changing. You know, they could start to consider the topography, what the site constraints would be. Was it a hilly site? Was it flat, etc.? Possible to generate good asset information. Again, straight away from the word go, you're going to understand how many windows are in there, how many doors, how many boilers, how many baths, etc. And because Revit stands for revise instantly, because you can actually make changes so quickly, it was very easy to actually create numerous drawings of different ideas, as well as being able to re-engineer any problems that we found. And the fact that at an early stage the schedules and the quantities were so accurate, they were getting a very much an easier ride from looking at, right, so this is how much material we're going to use, how can we reduce the waste, because we're going to be more accurate, we're not going to actually be getting to site and ordering too much because our quantities are so accurate to start with. Okay, so again, this was ways that they were saving money on the actual whole project. So what were the challenges that they actually had? So, you know, as soon as you go down to the house builders, particularly on smaller projects, it's going to be a smaller supply chain, yeah, and they're undertaking limited design to have the BIM capabilities. So, you know, not all of the supply chain from a lower end are actually going to be capable, if anything, or have the resources to actually supply BIM. So yeah, that is a challenge, but you know, you might have to do some of that yourselves. The manufacturing software, it didn't easily link to the design, although we are starting to see things change. So like when it says the timber frame required some coding from the software engineers to generate a file converter, but they produced that. If you actually have a look at some of the roof truss manufacturers now, they have got links direct with the design software that the plate manufacturers are supplying that will actually allow for bi-directional link, and I'll show you a model that was basically created using that software that's actually in a Revit file as well. It was a first project for them, so there's lots to learn. It is a learning curve. You are always going to have that little bit of a drop until you start to see the benefits. They weren't used to providing more detailed information earlier on in the project, because I mentioned that you tend to find that the project develops a lot faster in a short period of time. So there is a lot of more information being required earlier on. Procurement needs to be reviewed to engage teams earlier in the process. That goes straight back to the reason why I mentioned earlier about having a kick-off meeting. Yeah, having the documentation and looking at BS 1192.2 and seeing how we can pull that in. Yeah, and not all families of objects were available. So when we refer to families, we're talking about the windows, the doors, etc. So again, from a first stage project, this content has to be created. But you only ever create it once. Once it's created moving forward, if you're a house manufacturer or a house builder who's building the same house over and over again, or using the same style of windows over and over again, you've got your own style, then that content's available for you moving forward. So these were the targets that they actually achieved, yeah? And basically, a 10% reduction in design cost, measured at end of design and on completion, yeah, achieved. 20% reduction in construction costs, achieved. A 75% reduction in post-contract changes, yeah? These models are an accurate representation and an accurate prototype, if you like. So therefore we can look at them and there's no sort of hidden items in there. So we don't need to change the contracts afterwards because hopefully they were accurate to start with, and what was agreed to start with is exactly what was built at the end because we're not having to make them changes. 10% reduction in time on site, yeah? So basically this was fabbed, so prefabrication was done, so we actually were very easy to reduce that time on site. 25% reduction in notified defects. Again, we understand exactly how that building is going together. We can see it in 3D. We know that the kitchen cabinets are going to fit even though it was the first time it was designed because everyone's got involved, yeah? And 25% reduction in construction waste. Basically, the quantities that we took off were very accurate. In fact, sometimes I'd say they're too accurate because it tells you the exact amount you're going to need. All you need then is a good QS that just needs to add the correct amount of waste onto it, but you know that the value you've got is the exact surface of brickwork minus all the windows. We understand exactly how that's going to work. So let's have a look at this actually in practice and see how this actually works there. Okay. So what I've actually got is I've actually got a few house types already open. Let's just look at this. I seem to have had a slight hang on my machine, so we'll just wait for that to come back up. That's never good. Let's just relaunch Revit. And we'll just launch a couple of the house types back up for us. Okay. So let's have a look at the way that Revit works, and then we'll look at some examples of actually house types that have actually been put together by house builders as well. For those of you that have already got a copy of Revit and are interested in extra tools, if you are a Greatech customer, you are eligible for our Power Pack. This is a whole host of tools which are available to you. Basically it installs an additional ribbon at the top. Very, very powerful set of tools. If you have a look on our website at the moment, I'm currently running a series of webinars on some of the really nice tools that are in here. So this is a toolbar that adds extra functionality into Revit. Basically some of them are new tools, some of them are automation tools, etc. All in all, a fantastic pack of extras that are just going to make the use of Revit so much easier. So I just need to wait for this model just to update. It's quite a big model is this one. It's a large house type. So we'll just wait for that one to upgrade. Unfortunately it was upgraded before. Okay, so it's almost done. We'll wait for that to come up. Well, that's just doing that. I'm just going to open another copy of Revit just to show you the concept of how we would actually draw within the software. So we'll just wait for this to open. It shouldn't take 2 seconds, and I'll start a blank project. Here we go. It's just got to launch my Power Pack. There's the Power Pack launching, and let's go to new. So the whole concept behind BIM, and in particular within the way that Revit works, is that the content that we're creating is intelligent content. So even if I was just to come in here and draw a very simple rectangular building, I've got a wall construction, I've got the height, so I can specify the height. I'm just going to have a bungalow. I've got 2 levels in this building. and I can start to create the geometry for my building. Yeah. I can change the dimensions of how big or how small this building is. But if I was to come into this wall, if this was an AutoCAD wall, this would simply be a various sections of lines and some hatch patterns. But within BIM, it's more than that. So what I've actually got in here is I've actually got a brick block cavity wall with the plaster finish. And then I can come in and look at its makeup, and we can start to see that the finish is using brick common. If I come into the material, I can start to specify physical and thermal properties for the way that this works. So we can start to have a look at what the thermal properties are of a brick. By adding the materials in here as well, I've now got the ability to look at what the overall thermal resistance is for this particular wall construction. Resistance doesn't mean too much to most people, but what most people do recognise is when we look at the heat transfer coefficient, otherwise known as the U value. So this wall construction, based on the materials that I'm using, it's got a U value of 0.2. So straight away we've got the benefit of not only just designing, but the ability to maybe export this information out to our building analysis packages or building analysis people, and actually get the next level of information added into it. So some very powerful features straight out of the box for creating that. If I was to place a door, and let's just look at some of the content that comes out of the box packages. So I want an exterior door. I'll just particularly in this case use a single one, use that door there. Yeah, so I can now start to produce other information here, and I can pop that in. Okay, flip that over. That not only has cut the hole in the wall, if I was to select it, it understands it's a door. We can come into the settings, and we can start to look at everything from the material that's being used in there all the way down to who manufactures this door, etc. So straight away we're getting a lot more intelligent information, plus it's very easy for me to start placing my objects. If I wanted to have a couple of windows in that wall as well, and again we can go to load our content. The content I'm showing you here is delivers with Revit, so we'll have a couple of them, and it'll load that window style in. I want quite a large version of that. Okay, so I can place two of them windows in there. Now I mentioned that I only actually need to create plans. If I go to the elevation, it's already started to generate the elevational information for there. And then if I was to go to set that to a fine level of detail, if I was to go to a 3D view as well, look, we've actually already generated the 3D model as well. So straight out of the box, I've only simply drawn 4 walls, 2 windows and a door, but we're already starting to develop this model. And the speed at which we can actually do this is very quick indeed. So if I just go now back to that one, which annoyingly is still upgrading, let me just open up the other house instead. Let's open that one. So this is a model that's already been upgraded. The one thing to be aware of within Revit is you cannot save backwards, you can only save forward because of the changing features. So here we have a house type that's already been designed, and this can either be an end or a terrace. Yeah. What we've also got the ability in here to do as well is, I mentioned about being able to set up different scenarios. So what I've got here is I've actually got, is this an end unit, is it a mid unit? So we've got an mid unit. If I just go to set this to make that primary, so this is making this the primary solution within this design. Just delete that, make primary. This will allow us to select different solutions into the designs and make sure that we can actually utilize one design for multiple situations. Okay, so there we go. That is now the end one. Look, so it's brick. We've got the brick in there as well. What we can also do is I can then start to look at maybe different finishes. Yeah, so I just edit that. There we go. That's now changed that to be a rendered finish on here as well. So it's one model but multiple designs. And by changing what we call the design option in here, this will also update my schedule of quantities. So for instance, the different brickwork will now be taken into account. The renders will be taken into account. If I went to the end one, we'll just edit the end one. So there's now the end unit as well. So we've got one design that I can then utilize multiple times. So this would allow me to very quickly draw a row of terraced houses using this one design moving forward. So there's lots of things that we can do within the software that speed up and just aid us in our general day-to-day design process. Okay, here we go. So let's just ignore that one. So this model now that I've actually opened up here, at the moment, this is basically the Housebuilders house design. What I'm going to do is I'm just going to turn the roof off, which seems a little bit daft. But what I'm going to do is I'm going to turn the roof off in this view and do that. Okay, so you notice there's no roof trusses in that model at the moment. Some detail here, some on the eaves detail. But what we can then do is, depending on our supply chain and how well we pull that supply chain in, the one thing that's happened on this model is if I just go to insert and we'll just link in a Revit file, and what I've actually got, if I just go to my desktop and into here, we actually have the roof for this house design. So this is actually the roof trusses has designed using the MyTech software. So the guys at MyTech have developed a design tool which will actually allow us to create our roof truss. Notice that it's coming in the exact location. The other thing we've got then is we've got all the bracing being shown as well. When we pull the floor joist drawing in as well, where all the openings are, it will have the temporary bracing in there as well for the joists that have come in. So straight away, this has been through their analysis package, and we actually have the information then in here regarding each of these plates. Yeah, so we actually have the structural plates, etc. So the supply chain in general are getting involved. As I said, roof truss designers that are using the MyTech software have access to this as well. BIM is very much scalable, so don't be afraid to try it. BIM's here to stay. The benefits of BIM, when you look at it from a house builder's point of view, are huge. Particularly when it comes to change. If you've got a load of house designs and Part L changes, you can pretty much update your designs with maybe more installation or a different type of installation very, very quickly. So the time savings are there. The design savings are there as well. If you're worried that BIM is too big and you're looking at it from what the BIM Level 2 mandate is, maybe not look that far ahead. The Level 2 mandate is huge and covers all aspects of design. It covers everything from conceptual to renovation and retrofit, facilities management, and it's also been used, and I've worked with a demolition company who is already implementing BIM, and they're redrawing models from a BIM perspective to look at the easiest and most effective way to decommission and demolish buildings as well. BIM covers a very, very wide area. It more than covers everything that we do from a house builder's point of view, and there are benefits to be there. If you want to know more about it, if you'd like to speak to any of us and you want us to come in and see you, please contact your salesperson at Greytech or even myself, and I'll get your contact details across to them. It's been lovely speaking to you this morning. Thank you very much for your time. Hope that's been useful, and I look forward to seeing you all again shortly on one of our next webinars. Thank you very much.